Let us talk about GIS Fundamentals. First of all, GIS stands for Geographic Information System, and Geo is very important here. The PPT is from Dr. Briggs. So GIS, what is it? It's a complicated question basically. So geographic or geospatial information we have in GIS, this is G. So information about places on the Earth's surface. In a globe, the places, the location and the information. So knowledge about what is where and when, also the time. And the geographic, geospatial, these are synonymous. Means if we talk about geographic and stuff and geospatial stuff, they are equivalent. What is S in GIS? S is system, S is science, S is studies. So the system is the technology, the science is the concept and the theory, and the studies are the studies based on these results, means the societal context. Now, geographic information technologies, there are various technologies. Let us name a few. We have GPS, Global Positioning System. This is a system of Earth orbiting satellites which can provide, sub-centimeter accuracy and location on the Earth's surface, and that may be in lat long or any other way you would like to have. And the remote sensing, this is using of satellite or aircraft, we call it aerial photography, to capture information about the Earth's surface, because more high you go, more area you cover. And digital ortho images is also a key product, which is more accurate digital photos. Then this information system, GISy, the SY is for system, software system with capability for input and storage and manipulation, analysis, output, display of geographical information. So there has to be some technology which may be able to do these all input, storage, manipulation, analysis and display. GPS and RS are sources of input data. Okay, they act as a input data for this geographic information system, while this GISy, Geographical Information System, it provides for storing and manipulating this GPS and RS data. There are various other data which can be also inserted. These are the basic, important major data. This GI systems and GI science and GI studies, which all incorporate GIS. Which will we do? Means what are we talking about actually? We have systems, means technology for the acquisition and management of spatial information. Okay, the science, the comprehending the underlying conceptual issues of representing data and processes in space time. The theory and concept behind the technology, that is the algorithm, the technology which are made on account of or for the benefit of these GIS systems. Then the studies, understanding the social, legal, ethical, these are just few. There are many issues associated with the application of either geographical information system or geographical information science. Okay, this is what we are talking about. And before we go ahead, let's define GIS. The common ground between information processing and the many fields using spatial analysis technique. This was by Tomlinson. A power of set of tools for collecting, storing, retrieving, transforming and displaying spatial data from the real world. This is by Burrow. Now this is very important, that wherever we are talking about spatial data, spatial analysis and spatial stuff. Spatial is the location, it has to have a location. Then we have a computerized database management system for the capture, storage, retrieval, analysis and display of again the spatial data. And finally, one more definition is the decision support system involving the integration of spatially referenced data in a problem solving environment, because what we are doing is we are having a data together, we are manipulating it and we are having some functionality just because we need some problem solving, we need some decision making. One more definition of GIS is a system of integrated computer based tools from end to end processing. All this means, which is a database stuff basically, of data using location on the Earth's surface for interrelation in support of operation management, decision making and science. So whatever we are doing related to geography and related to decision making. So we have a set of integrated tools for spatial analysis. We have end-to-end processing of data. All these, capture right from capturing to display in a specific form, and uses explicit location on Earth's surface to relay data. And it is aimed at decision support, because as well as ongoing operations and scientific inquiry, which is important because data will not solve anything until unless you are able to pick or get some information out of it. There is an intuitive description also for GIS. This is a map with a database behind it, you can say that, or a virtual representation of the real world and its infrastructure, again you can say that. And the consistent as built of the real world, natural and man-made, the way you would require your geography or your system to give you output as a common or a layman. This is what it is doing. Okay, so which is this all is queried to support ongoing operations. It is summarized to support strategic decision making and policy formulation, and analyzed to support scientific inquiry. So there is analysis, there is decision making, there is making of algorithm, there is putting geography into on the background. All these things are the intuitive description. So how this GIS differs from the related systems? DBMS, this is the backbone of GIS. So DBMS is typically MIS data, means information system database containing implicit but not explicit locational information. Like it may have city, county, zip code, but may not have a geographical coordinate. It may be 100 north, high around the corner or across town from 200 E main. What if we want this line, this data? If we equate GIS with automatic mapping, let us see what is automatic mapping. This is primarily two-dimensional display devices. We have a thematic mapping. This is unable to relate different geographical layers, okay, with the thematic mapping. And automated cartography means graphical design oriented and limited database ability. Automated mapping is somewhat limited, so it cannot be regarded as GIS. Then facility management, like LAG, spatial analysis tools. This facility management, it should have a spatial analysis tools so that we may make it synonymous to GIS. Then CAD/CAM, computer aided design and drafting. So it is primarily a 3D graphic creation of basically engineering design and display system. So we don't reference via geographic location and CAD and CAM, though CAD and CAM has now been powered with geography systems also, and this is limited to this has the limited database ability also. And the scientific visualization system, they are sophisticated multi-dimensional graphics, but it does not have a database support, or it does not have a two-dimensional spatial analysis tool. So what are all these lacking? It may be taken out. They will all be in GIS. So why study GIS? This is an important question. Why would we be talking about GIS? 80% of the local government activities estimated to be geography based. You may talk about electricity department, water department, human resource department, any department. You need to have a zoning, plots, public work, garbage collection, land ownership, valuation, public safety. Everywhere you need to have some geography involved. So a significant portion of a state government also have like geographical component, as I mentioned, national resource management, highways and transportation. Business also uses GIS, like retail site location, vehicle tracking, natural resource exploration, agriculture, civil engineering, construction. Everywhere you need GIS. Military, you have battlefield management, satellite imagery interpretation, also GIS. Then scientific research like geography, geology, botany, anthropology, sociology, economics, political science, even epidemiology and this criminology also requires GIS. Sir, where most UTD students come from, go to the major areas of GIS application. We are actually talking about those people who are actually interested in GIS, they go to local government, they go to real estate and marketing, they go to public safety and defense, they go to transportation, they go to natural resource exploration, public health and epidemiology, and the geospatial industry. And these are the examples of applied GIS. GIS is a subject, but where it is applied, then it becomes applied GIS. It is applied on urban planning and management policy, environmental sciences, political sciences, civil engineering, businesses, education and administration, real estate and healthcare. And these all things which are the sub part, they are actually based on some or the other algorithm which is developed by people who are working in GIS. Okay. So what GIS applications do? It manage, analyze and communicate. GIS application does all this. So it makes possible the automation of activities which involving geographic data, like map production, calculation of areas and distance and route lengths, measurement of slope, aspect, view shed, logistics like route planning, vehicle traffic management. It also allows for the integration of data, to confine independent domains. And this is done by tying data to maps, permitting the communication of complex spatial patterns. It also provides answer to spatial queries, like how many elderly in Richardson live further than 10 meters at rush hour from a service. It performs complex spatial modeling. Okay. So this is GIS system architecture and components. We have data input. This is the query which is given to geographic database. There are display and reporting. There are analysis and transformation. A knowledge base for GIS, of course, computer science, geography is involved. All these combined, there are application areas. So the convergence of technological field and traditional disciplines makes a GIS so important. Now the GIS data model, let us see about that. The GIS data model, the purpose of this is to allow the geographic features in real world location to be digitally represented and stored in database. So all the information will be kept in database, but they has to be spatial, so that they can be abstracted or abstractly presented in a map form. Map is analog, and which can also be worked with and manipulated to address some problem. This is important because there has to be some problem. Because if GIS is not able to solve the problem, we will not be talking about it. See, this is the real world. These are the geographic features, and this is the abstract representation. This is how we represent it. And now we have the map and the data for analysis in front of us. This is a layer cake of information. This is what we have actual view on the globe, and these are the parcels, districts, streets, soils, utilities, land use, topography, hydrology. Whichever you want, these are layers. You can place it and you can work it out. Your problem you can be easily solved. So the GIS data model, the implementation is that the data is organized by layers. These are the various layers, and these are layers also. These are coverages also, or you may call it as a theme. So with each layer representing a common feature, you can also call this, every layer may have different theme. So layers are integrated using explicit location on the Earth's surface. So thus this geographic location is the organizing principle. This is the GIS model. Let us take an example. Here we have three layers. We have road, we have hydrology, and we have topography. So these can be related because precise geographic information are recorded for them for each theme. Okay, layers are comprised of two data types: spatial data or attribute data. Spatial data, which describe the location, means where, it answers the question where, and attribute data. Attribute data specifying what, how much, when, means related data to the spatial data. And layers may be represented in two ways. It may be vector, it may be raster. Vector are point line polygon, raster are in the form of pixels. So the all geographic data has essentially four properties. It has projection, it has scale, it has accuracy, and it has resolution. So spatial and attribute data. Spatial data, as we mentioned earlier, it is where, it specifies the location. It is stored in the form of shape files or geodatabase or related geographic file. While the attribute data, which answers, this is description basically of this spatial data, of what, how much, and when. So it specifies characteristics at that location, natural or human created, and it is stored in the form of a table, of course in the database. So GIS system traditionally maintains spatial and attribute data separately, or then they join them for display or analysis. For example, in ArcView and ArcGIS, the attributes of table is used to link a shapefile with a database table which contains the attribute information in order to display the attribute data spatially on a map. And then how to represent this raster and vector data? There is a raster model, there is a vector model. Raster model is the area, or the area which is covered by a grid which are essentially equally sized square cells, and the attributes are recorded by assigning each cell a single value based on the majority feature in the cell, such as land use type. And image data is a special case of this raster data, in which the attribute is a reflectance value from the geomagnetic spectrum, okay, electromagnetic spectrum you can say. So the cells in image data are often called pixels, okay. This is pixels or picture elements. Vector data, the fundamental concept of vector GIS is that all geographic features in a real world can be represented either in the form of point or line or polygons or areas. You name any feature on this globe, you can always represent it in these three geometries, okay. So because representation depends on shape, ArcView refers to files containing vector data as shape files. We are specifically talking about ArcView or ArcGIS because this is the famous proprietary software which is available. So the concept of vector in raster is, this is the real world, this is the raster representation, okay. Now this vector, this is the vector representation, this is a raster. Raster has in the form of pixel, while the vector representation is in the form of point, line, polygon. These are the images or smart GIS database. We have smart vectors, pavement, polygon. See, these are the vectors, and these are the smart raster 5 feet grid, okay. These are the 5 feet grids. So these are actually the way how we can represent this in the form of pavement polygons, how we may represent this in the form of grids. This is how we can represent it in the form of our tables, information, attributes. Now the projection, scale, accuracy, resolution. These are the key properties for any spatial data. If you talk about spatial data, you will first start what is projection, what are the scale, or what is the accuracy, or what is the resolution. So the projection is the method by which the curved 3D surface of the earth is presented by XY coordinate or not 2D flat. So basically representation of 3D surface on a 2D surface, 2D flat screen is the projection. So distortion is inevitable. There are various projection which saves shape, distance, area, okay. This is a separate topic. Now the scale, the ratio of distance on a map to the equivalent distance on the ground. Because map is small, the area is very large, so you have to have a scale so that a user can convert it. And the accuracy, there are various accuracy. How well does the database information match the real world? That is the positional accuracy, the consistency, and the completeness. These are also the aspects of the DBMS. And the resolution, the size of the smallest feature able to be recognized. Okay, this is called the pixel size, or in the raster data we call it a pixel size. So the tighter the specification, the higher the cost. Let us take the example. These are layers, right? These are vector layers, okay. These are point, line, polygons. We don't have a point, but still we have a line and polygons. And these are the street network layers, lines. These are the land parcel layers, and this is the raster image. This is a digital ortho photograph layer. And digital orthophoto, it combines the visual properties of a photograph with the positional accuracy of a map in a computer aided form. So this has a projection, this has a resolution, and this is the accuracy, also a scale. See, this is a scale. And this is the overlay based on common geographical location. You take this, you took this, you take this, and just overlay it. You see, everything is available now. So the analysis is data table. These are the object IDs, these are the tax IDs, these are land key, these are the additional information. So you have the information of each and every feature in hand available to you. This is a photographic image. If you want, you can also have a photographic image of that particular point or area. This is what you have, a scan drawing. This is also available. So how we make a vector layer, how we can make attribute tables, how we can have raster layers, all these are available in your GIS, that is Geographic Information System, and this is essentially a type of software. So we have GIS software packages. We have the main players are ESRI. This is one of the topmost proprietary software maker, and in every school, colleges, in universities these are been taught. Then we have MapInfo, Intergraph, and Intergraph has some very good ADAS imaging thing. Then Bentley software, Autodesk, all of them are there and they are very good. Then software for GIS, there are other players also. For vector we have Small World System, Manifold, Maptitude. For raster GIS we have ADAS, ER Mapper, NV, PCI, Caris, Gross, ESRI, and Quantum GIS. Now most of them has been taken over or purchased by the other. So it may happen to you when you are finding this video. One may have purchased the other. Then ESRI product lineup, ArcGIS client products. We have ArcGIS. I am talking because this is a very important, our vector based GIS. So it has ArcReader, ArcGIS, ArcGIS Workstation, ArcGIS Engine. All these are in ESRI product lineup for client products. And if we talk about ESRI server product, we have ArcGIS Server, ArcGIS Online Services also available. So this is ESRI ArcGIS systems. We have some, client system. We have our server systems. So these are all available. But whenever you are finding it, you must be very sure that things have changed drastically in coming years. And this is the future generic GIS internet enterprises. This is the web, because we are talking about web now, so it has to be web GIS. These are the browsers on web, these are the applications, these are the brokers, these are the web server, maybe in some place X, Y, Z, and these are the services. Will be using .NET, SOAP, XML, and Java API. So thank you so much. Hope you had a basic idea of what is GIS and what are the spatial data. Thank you so much. Take care.